on.
Okay, so the major factor in the development of the technology is been getting it, first of all, getting the IP through its various iterations. There's been 6. That means the intellectual property changes. It morphs. You need to make it better, you need to make it better, you need to make it better. You need to get it to the point before you commercialize where somebody else can't make it better.
Mm-hmm.
If somebody else can make it better, they will, and then you're out of business. Okay? So in 2000, this coil here is the one I'm going to show you first.
Mm-hmm.
It's a 2008 version. It has a Regenex generator coil, 2 of them, okay? On the inside, this is called an E core. It's got an E-shaped core. And it has a conventional coil on the outside. So it's going to demonstrate from the conventional coil, conventional generator operation, generator armature reaction, deceleration, you're going to see that.
Got it.
Okay? And then when I engage the Regenex coil, you're going to see regenerative acceleration. You're going
This
to
is yours.
This is ours.
Got it. Okay.
Put together.
Okay.
The original prototype, this one, had a Regenex coil,
Okay.
which created acceleration, married to a conventional coil, which produced deceleration.
Got it.
Okay? And if the acceleration produced was more than the deceleration produced, you ended up with a net acceleration under load. This is what this one is meant to do. But this one also shows the load current sine wave. Okay, this is very important. It's part of your document. Shows the load current sine wave for the conventional coil, the current sine wave. Okay, and that establishes the physical position of the rotor magnet on where it is with relationship to the coil. Okay, how close it is. If you know how to understand the sine wave, and it's explained, but if you know that, then you know where the magnet is with the relationship to the core. Okay, when the Regenex coil is engaged, the system accelerates. It has its own load current sine wave, and it's delayed in the time domain. Okay, this is where the whole thing works. Okay, so this prototype that I'm going to show you next shows the load current sine wave and the prototype that we had available in 2008, which our first patent is issued on.
Okay.
Okay, from there. And again, this is a 2-coil version, okay?
Mm-hmm.
The intellectual property needed to go from a 2-coil version to a 1-coil version, which has happened in 2010.
Mm-hmm.
This is a 1 amp coil,
Okay.
okay? This, you're going to see, this is about 1 amp as well,
Okay.
okay? Not a lot of current, okay? So as the intellectual property matures, it goes from 2-coil to 1, and then from 1, which is good, to 10 amps and beyond, okay?
Now is this yours or?
This is ours. This is a commercially manufactured version
Mm-hmm.
of this. This
This is the new. This is your coil.
This is ours, okay? And then if you just want to slide over here, the gold coil that's on there, on that prototype, that's a 100 amp coil.
You mean that?
Yeah.
Right there, to be specific.
Yeah, that is a 100 amp coil.
Got it.
So, 1 amp,
No, that's your coil though?
that's a commercially manufactured version of our coil.
Got it.
But what I'm trying to impress on you is 1 amp 2008,
Mm-hmm.
no patent.
Mm-hmm.
1 amp 2010, no patent.
Mm-hmm.
10 amps 2018, patent. 100 amps, 2019 patent,
Got it.
okay?
So
If
you're
you
ready.
can go from 1 to 10 to 100, you can go to 1,000,000 amps. There's no restriction,
Got
okay? Got that?
Got it.
That's important, okay? So now I'm gonna show you the load current delay. I'm gonna show you the gold coil. I'm also gonna show you the latest version, operating in regenerative acceleration mode, and then operating in conventional mode. And we're gonna show you and explain to you exactly what the difference is, okay? And then I'll show you the transformer, because that's important as well. And then we'll do the motorcycle.
Okay.
Okay? Cut?